Okay, hello. In this video, I will be introducing to you the concept of derivatives and some of the basic rules surrounding it. Okay, so the first question is, what are derivatives? So in previous grades, you have learned that the slope of a linear graph, like, I don't know, let's go here, in this linear graph, it is rise over run. I would put R here, and Ri, rise over run. So how would you find the slope of something like a quadratic? Let's say its equation is y equals x squared. So first of all, you can represent the slope at the instantaneous, like the main concept of a derivative is a graph's slope at an instantaneous point, like let's say 1 and 1. This point, what is the slope of the graph at that specific point? A nice way to represent this is drawing a tangent line to it, which I had already drawn. So it's the slope of this line, which is the same thing as rise over run, like I've stated over here. So I'll be telling you how to find the slope of various different functions. First off, it won't be like a certain slope of a function, because for nonlinear functions, a slope is something like a function that when you plug a value, an x value into the derivative function, it will give you back the slope at that specific point. And if you don't understand that, you'll see what I mean when we move on. Okay, so first off is the power rule. This is the most basic of the rules. This will also help us solve the y equals x squared problem. So let's write this out. Y equals x squared. So the power rule states that you multiply this power by the coefficient. And since the x squared's coefficient is technically 1, we can just add a 1 here, it will be just 2. You keep the x, and you minus this power, subtract this power by 1. So 2 minus 1 is 1, so we could just put 1 here, or we could just leave nothing here because 1, you could just leave that. So the derivative, or y prime, which is a way of writing a derivative, equals 2x. Another common way of writing a derivative is dy over dx. The y stands for the function, like y, it can be f, it could be anything else, and x stands for, well, x, so, yeah. And d stands for the infinitesimal change. So the infinitesimal change of y over the infinitesimal change of x. So let me show you how to apply this over here. Okay, so first off, let's write that out again. Let me choose another color. Let's say yellow. Y equals 2x. So if you plug in 1 here, which will correspond to this x value, you can say that y equals 2 times 1, which is 2. Which means that the slope for the corresponding point of this one, which in this case will be 1, 1, the slope of that instantaneous point, or the slope of the tangent line, is 2. Okay, let's move on to some more advanced power rule. Let's say it's y equals 2x squared plus 7x plus 5. Okay, since 5 is a constant, we can say that the derivative of this is 0, because when we say like a line, like y equals any constant, like, I don't know, let's say 5 again, it's a horizontal line in which the slope is 0. So we can differentiate the non-constants separately and then use this addition sign to, combine them together. So let's go. So 7x, 1 times 7, 7. And x to the 0th power is 1, so 7 times 1, or just 7. Plus 2 to the 2nd power, which is 4. 4x to the x to the 1st, aka 4x. So this will just be 4x plus 7. The main power doesn't always have to be a 2. It could be a 1, it could be a 3, it can be any power. It can even be fractional, negative. It could be anything. So let's move on. Next off, we have the product rule and the quotient rule. The first thing I'm going to be covering is a product rule. It's when you have two functions and you multiply them by each other. You may note that it doesn't have to be a function, like a function with separate graphs and stuff. It could just be something like x squared plus 7 times, because that's the use case in this scenario, 9x to the 3rd. So the general formula is a, like you can, like a or b, you know, they're arbitrary, like you can switch them up, like a prime b, and then the derivative of a times b, plus b prime a, as in b prime times a. So how would you do this? So first off, you use the power rule for these. So let's arbitrarily define x squared plus 7, let me switch back to orange, as a, and 9x cubed as b. So let's solve. So a prime, as in the derivative of a, since 7 is a constant, that part will be 0. And x squared we've already covered is 2x. 2x multiplied by b, as in just regular b, 9x cubed, plus b prime, as in the derivative of 9x cubed, 3 times 9, 27, x to the 3 minus 1 is 2, multiplied by x squared plus 7, which I will put here, so 2x times 9x cubed equals 18x to the 4th plus 27x squared times x squared equals 27x to the 4th. (27x to the 4th) plus 27x squared plus 7, which is 189. Let me add a plus sign here. 189 x squared. So if you simplify, it'll be 18 x to the 4th plus 27x to the 4th. So that would be 45x to the 4th. Plus 189 x to the 2nd, which happens to be our answer. Okay, so the second rule in this pair of rules is the quotient rule, which is the use case of like a certain function. Again, it doesn't have to be a function. It means like these sort of things divided by one another. And I'll use the same set of numbers just to make things so much, like, a lot easier. Let's make it so that it is x squared plus 7 over 9x cubed. And you find the derivative of that. Okay, so the formula is bottom times the derivative of top minus top times the derivative of bottom over bottom squared. So let's find this out. Gx squared, so 81, 9 squared is 81, 81, and x3 squared is x cubed squared is x to the 6th. So let's begin the actually somewhat difficult process. Okay, so we can say 9x cubed times the derivative of the top one, x squared plus 7, which we've already covered as 2x, minus x squared plus 7 times 27x to the 2nd. We've already covered 9x cubed times 2x is 18x to the 4th, from the previous problem. Minus, and we've already covered this, is just 27x to the 4th over 189 over 2, here. And for simplicity, that's why we've been using x squared plus 7 over 9x cubed, just for simplicity's sake. And since there's a parentheses around here, you can also just say minus 9x to the 4th minus 189x squared over 81x to the 6th. Is there any way we can simplify this? Yes, we can simplify these x's, right? So we can divide all this by x squared. So we can say minus 9x squared minus 189 over 81x to the 4th. Now, there's one other way we can simplify this further, because each of these coefficients, well, this is technically not a coefficient now, it's a constant, but each of these have a factor of 9 in them. So what we can do is 9x to the 4th negative x squared minus 21, which is 189 divided by 9, and this also happens to be our answer. Okay, third and final rule that we'll be doing is the chain rule. It is j of g of x, the chain rule. So a example problem we'll be using for this is sine of x squared plus 7. So I'm not getting into the derivatives of trigonometric functions, but the derivative of sine, that'll be for another video. But sine derivative is cosine. When I say equals, I mean like derivatives, because I just don't want to put that out. Cosine equals negative sine. So the general formula is j prime of g of x times g prime of x. So let's take that in action. So sine of x plus 7, so the j in this case is sine, so j prime, we've learned is cosine, of, and since it's g of x, this is the g of x, so x squared plus 7 and it's multiplied by the derivative of x squared plus 7, which we covered so many times, to be 2x. And that so happens to be our answer. Okay, now time for practice problems. If you're willing to solve these problems on your own, feel free to pause the video, and I will wait a few seconds so you can unpause and we can solve them together. Okay, so I assume you've paused the video and solved them for yourself. So the first rule is about the power rule, the second rule is about the product rule, the third rule is about the chain rule. The reason I didn't include the quotient rule is just because it would take too long, take too much space. So let's get started. Number 1, we'll put over here. I'll use a different color this time. Let's say blue. 2x to the fourth, the derivative of 2x to the fourth is 4 times 2, 8, x to the third, 4 minus 1, 3, plus, this is x to the 2/3 power. As I've said, the power rule also just works for fractional exponents. So 2/3 times 1 is 2/3. X 2/3 minus 1 is negative 1/3. And since the derivative of 7 is 0, we don't really need to include that, so this is our answer for the first one. The second one employs the product rule, which I'll do in green. I'll bring this over here. S squared plus 7 times x to the 5/3. What's the derivative of that? Well, we'll find out. Okay, so x squared plus 7, we've already covered this so many times. It's 2x times x to the 5/3 plus, what's the derivative of x to the 5/3? That is 5/3 times 1, so 5/3 x to the what's 5/3 minus 3/3, 2/3 times x squared plus 7. So the first term is 2x times x to the 5/3. So since we just add the exponents, 1 plus 5/3 is 2x to the 8/3 plus 5x to the 2/3 times x to the second. So again, we just add the exponents. So 6/3 plus 2/3, which is also 8/3. Plus 7 times 5/3 times x to the 2/3 is 35 times x to 2/3 35x to 2/3. So if you add these up, it's 6/3 plus 5/3 equals 11/3 x to the 8/3. Sorry, I made a mistake. It's 35/3 plus 35 x to 2/3 over 3. Okay, for our final question, I'll be using the purple, and it is cosine of x to the 5/4 plus 7. So the derivative of cosine is negative sine. Sine of x to the 5/4 plus 7 fourths plus 7, and then multiplied by the derivative of, since we don't really care about this plus 7, we can say 5/4 x to the 1/4 fourth, which also is our answer. Now we're done with this video. I hope it helped, and happy cramming.